Assalamu alaikum everyone. I hope you all are fine. We'll continue our first chapter today, and our today's topic is types of sets. So let's start. Okay, so first one is finite set. A finite set contains a finite or limited number of elements. It means that the elements are countable. We can count them. For example, a set of number of days in a year. So we know that there are 365 days in a year. Next one is a set of perfect squares less than 20. So we know that 1, 4, because 4 is a square of 2, then 9 and then 16. So there are 4 elements in this set. So a set in which we can count the elements is called finite set. Okay, the next one is infinite set. Infinite set is a set which contains an infinite or unlimited number of objects. Okay, so unlimited, it means that we cannot count the elements of that set. For example, a set of number of stars in a sky, and we cannot count the stars in the sky, so it is an infinite set. Okay, the next one is a set of integers greater than 10. Okay, if we write integers greater than 10, it will be 11 plus minus 11 plus minus 12, because integers are positive and negative, is 13 plus minus 14 and up to so on. So it goes to infinity, so we cannot count the elements of this set, so it is an infinite set. Unit set. Okay, a unit set is a set which contains only one element. It is a set that contains only one element. That is why it is also called singleton set. Okay, single elements, so we also call this set singleton set. For example, the set A is equal to 2. Okay, this set, it can be any set like B is equal to 4, or C is equal to A. So as a unit set contains only one element. Okay, next one is empty set. Empty, it means the set is empty, means it contains no element. It is a set that contains no element. That's why it is also called null set or void set, and it is denoted by this or this symbol. Because it contains no element, so we can also write this set as this, or we can also use this symbol. It means that this set is empty. For example, if it is written, if a set is empty, so we can write a is equal to this, like with no element inside, just brackets, or we can also write a is equal to this. It means that a is an empty set. Okay, so the example is written here: a set of names of months beginning with K. Okay, is there any name of month that begins with K? No, it's not. It means that this set is empty. Okay, so next one is disjoint sets. Two or more sets are called disjoint sets if they have no common elements. Means two elements with no same element is called disjoint sets. For example, E contains 2, 3 and 4, and F contains 5, 6 and 7. So there is not a single element that is same in these both sets. So E and F are called disjoint sets. Okay, overlapping sets. Two or more sets are called overlapping sets if they have at least one common element. It means that two sets having few or some or just one common element are called overlapping sets. For example, set G contains 1, 2 and 5, and H contains 2, 3 and 5. So this 2 is same in these both elements. Okay, so if we make Venn diagram on these overlapping sets, it will be like, for example, this is set G, okay, and we will write, and it contains 1, 2 and 5. And if I make H, it contains 2, 3 and 4. So this element, this 2 is same in both sets. So we can make a Venn diagram on overlapping sets like this. This portion is for common elements, this one. So here the 2 is common element, so we will write 2 here, here, and this is G and this is H. 1, 5, 3, 4. So this is how overlapping sets can be shown through a Venn diagram. We have studied Venn diagrams in our previous video, overlapping sets. And if we make a Venn diagram for disjoint sets, it will be like this, because they contain no common elements. So E and F, they will have separate circles for them and the elements written inside, because they have no common element. But for overlapping sets, we make Venn diagram like this and we write common elements inside this portion, that is common. Okay, so next one is equivalent sets. Two or more sets are called equivalent sets if they have an equal number of elements. Okay, two sets having equal number of elements are called equivalent sets. It is not necessary for them to have the same elements. It means that only the number of elements should be same, not the element itself. For example, J contains 1, 4, 6 and K contains 1, 4, A, B, C. So they have different elements, but if we count the number of elements, here J contains 3 elements and K also contains 3 elements. So number of elements are same. So these two sets are equivalent sets. So two sets having equal number of elements are called equivalent sets, but it is not important, it is not necessary for them to have the same elements, just the number of elements should be same, not the elements itself. Okay, the next one is equal sets. Two or more sets are called equal sets if they contain the same elements. Okay, now here they should contain the same elements, means the number of elements and the elements itself should be the same in both sets. For example, L 2, 4, 6 and M. Here two sets. L contains 3 elements, which is 2, 4, 6, and M contains X. X is a positive multiple of 2 where X is less than 7. Okay, so this M set is written in set builder notation. So first we should write it in tabular form so we can see which elements it contains. Okay, X is a positive multiple of 2 less than 7. So we have to write multiples of 2 but less than 7, means 2, then next is 4, then 6, and then is 8, that is greater than 7, so we will not write that. Okay, so now count the number of elements, 1, 2, 3. So it contains 3 elements, and L also contains 3 elements, and all the 3 elements are same, 2, 4, 6, 2, 4, 6. So these two sets L and M are equal sets because they contain the same number of elements and the same elements. Okay, so I hope the both definitions are clear now, equivalent sets and equal sets. The only difference is that in equivalent sets, only the number of elements are same, not the element itself, and in equal sets, number as well as the elements should be same. Okay, so last one is universal set. It is a set which contains all the sets under consideration. Okay, under consideration, it means that this is the biggest sets in which all other sets belongs. All the elements of other sets are present. So it is the biggest set under consideration. Under consideration means, for example, here two sets are written. Set J, which contains January, July and June, and A set contains April and August. So these are all name of months. J set contains the name of month that begins with J, and A set contains name of months that begins with A. So what will be the universal set for these two? It should be a set containing all the name of months. So U is the universal set is always denoted by capital U. So U set contains months of the year. So it means that if universal set is months of the year, so it will contain all those sets which contains the name of months. Like J is present in U, A is also present in U, so U is a universal set for both J and A because it contains all the elements of set J and A and some more. Maybe if I make another set like B and it contains only February. So U is also a universal set for B because B is also present in U. Okay, now if we look at the Venn diagrams for universal set, I think yes, we have already discussed this universal set in our previous video when we were discussing Venn diagrams. Okay, so here is a Venn diagram for universal set. This U, like this portion, this all portion is universal set. This full is universal set and it contains J, which is this, and A, which is this. So J and A are present in this set U. J and A are present in this set U. So this is how a Venn diagram for universal sets are shown. Like we make a big rectangle which is U, that is universal set, and all the sets are written inside this rectangle. These two are disjoint sets because they have no common element. Here January, July and June, and here April and August. So if they were overlapping sets, then they would have here a common place just like we did before. So I hope the universal set is clear now and all the types are clear now. Okay, so these are some questions from your exercise. First one is the following set finite or infinite? We have to tell these two sets are finite or infinite. Okay, first one is set of cities in Pakistan. Can we count the cities in Pakistan? Yes, we can. So it is an finite set. I am writing F for finite. Okay, next one is set of points on a line segment. Okay, a line segment is a part of line that connects two points. For example, if I have a point here and here and I connect, so this is a line segment. It has two end points. Okay, so can we count the points on these line segments? No, we cannot count because there are infinite number of points on this line. We cannot count them. So this is an infinite set. I'm writing a capital I for infinite. Okay, the next question is which of the following are equal sets? Okay, equal sets, it means that the number of elements and the elements itself should be same. Okay, the first one, here there are three elements and here also, so the number of elements in both sets are same, but here the elements are 2, 3 and 4 and here 3, 4 and 5, so they are not same. It means that they are not equal set. Okay, this one, here A is a set which contains only one element, that is 0. It is a singleton set, and B is an empty set. So here the number of element is 1 and here the number of element is 0, so they are also not equal sets. Okay, the last question is which of the following are equivalent sets? Okay, for equivalent sets only the number of elements should be same. Here the number of elements are 1, 2, 3, 4, and here also 4. So they are equivalent sets. We just have to see that the number of elements are same or not. Okay, so this is an equivalent sets. Okay, the last one. Here is a set L which contains how many elements are here? 1, 2 and 3. So here the number of elements are 3. But here the number of elements are 1, 2, 3, 4, 5, 6. So here there are 6 elements. It means that they both are not equivalent sets because they don't have the same number of elements. Okay, here because the elements are always separated by commas, so you can see here there are only 2 commas. It means that only 3 elements are here, 1, 2 and 3. But here element each number is separated by comma. It means that there are 6 elements here. So I hope all the types are clear now. And if you have any question, then you can contact on school's contact number. Thank you. Allah Hafiz.